What is up, nerds? Welcome back. Yeah, last video. Uh, what did we do again? I forgot. But yeah, if you want to know, you can check it out. In the playlist, I would have made a playlist by now for all of these videos, so you guys can know where they all are. So it can be very convenient for you. So, today's video, we will be doing problems about finding slope-intercept form, find a distance between 2 points, find an equation of a line, all of the good stuff. So without further ado, let us go ahead and get started. All right, so here we got two problems here. I don't know how many we're going to do today. Depends on how much work is required to do each of them. So we're going to try to at least do one of each different type. But starting with this one here, we're going to find the slope of a line and find the slope of a line through 2 points. So one, finding the slope of a line given the standard equation of a linear equation. And then the other type of trying to find the slope of a line will be if we are given 2 points. So the first one, find the slope of the line 3x minus 5y equals 8. Now, again, as I said, this problem, they're giving us an equation in its standard linear equation form. That is ax plus by equals c. That's our standard linear equation form. And they want us to find the slope. Now, when talking about slope, we should know that the slope is the value or coefficient that's always correspondent with the x variable when we have the equation set equal to y. So it's important that I add that there, because if I just left off that part, you would say, well, the 3 would be the slope, when that's not the case, because the equation is not in the form what's called slope-intercept form, where the standard equation is set equal to y and not in this standard form that we have here. So that's the idea. In order to find the slope in the standard form, we need to change it in the slope-intercept form, or get the y by itself, solve for y. So I'm going to write down the 3x minus 5y equals 8 and solve for y. So doing a regular algebra problem that we always been doing when trying to solve for a variable. So first thing first, I'll need to subtract 3 on both sides of the equation, 3x. So that leaves me with the negative 5y equals, and I'm going to put the minus 3x first, minus 3x, and then the 8, since it's positive, be plus 8. All right, so now I need to get rid of the negative 5. So divide both sides of the equation by negative 5. So on the right side, the negative 5 will be divided into any and every term that is over there. So the negative 3x and the plus 8, that negative 5 gets divided into both of those. So I will have y is equal to a negative divided by a negative is a positive. So I have 3/5 x, and a positive divided by a negative or vice versa gives me a negative. So this is a negative 8/5. So now that I have it in the form that we wanted in, slope-intercept form, y equals mx plus b, that is what that is. Slope-intercept. I'm going to go ahead and write the one from earlier, the standard So now that I have it in the slope intercept form, again, what I said, the value or coefficient that is with the x value is our slope. And in the general form for it, that is the letter M. We use M here to represent the slope of a linear equation. So now that I have it in that form, y equals whatever, all I have to do is identify the coefficient that is with the x, and that is the 3/5. So therefore, my slope, or M, is equal to 3/5. All right, so now moving on to the second one. Okay, so you see we have here finding the slope of the line that's going through these 2 points, -3,6 and 5, -4. So in order to solve this type of problem, we need to use what's called the slope formula. We have a formula to find the slope, and I will write that down here. M is equal to y sub 2 minus y sub 1. That is divided by x sub 2 minus x sub 1. Now I can get into about the order of the y2, y1, and x2 and y2, but we're just gonna leave it as it is here. No need to get into that. So we're gonna follow the formula to get the slope. So y2, y1, x2, x1. What do those represent? Those variables represent the values of our order pairs, or our points, the -3, 6, and the 5, -4. We know order pairs consist of x values and y values. So for the sake of order, the point -3, 6 is going to be our first point, and the point 5, -4 is going to be the second point. So with labeling, again, as I said, order pairs consist of x values and y values. So our first point, -3, 6, that is our x1 and y1. So then our second point, the 5, will be the x2, and the -4 is the y2. So now that we have our order pairs labeled properly, we can go ahead and use this formula to find the slope that goes through these 2 points. Slope of the line that goes to these 2 points. So slope equal to, let's see, y2, which is a -4, minus y1, which is a 6, divided by x2, which is a 5, minus x1, which is -3. So I'm going to enclose that in parentheses, so I won't have 2 lines meeting together. So I know what's a negative and what's a minus sign. So now I'll just evaluate. -4 minus 6, that gives us a -10. And then 5 minus a -3, that's the same thing as saying 5 plus 3, that gives me 8. So here I have a -10 over 8. We always want to simplify if it can be done. So -10 over 8 gives me a -5/4. So the slope of the line that goes through those 2 points is a -5/4. So being pretty easy in the beginning. So yeah, to get our brains warmed up, so we'll be ready for the next few problems. So with that being said, let's go ahead and go to those next few problems. All right, so the next 2 problems here, these are where we're going to be doing a little bit more work here. So finding the slope-intercept form of an equation of a line that goes through a point and is perpendicular to another line. And then the other one, same type of problem, finding the equation of a line of slope-intercept form that goes through a point but is parallel to the line that goes through 2 points. So yeah, a little bit more work that we're gonna have to do, but that's okay. So starting off with the first one, we need to find the slope-intercept form. So that's y equals mx plus b. We need to have it in this form of the line that goes through some point. That point is 1, -2. And it's also perpendicular to the line given, 2x minus 3y equals 6. Well, we know if we were given just the slope, if we was already given the slope, we could find the equation of the line of slope-intercept form with the information that was already given. Where we use what's called the point slope form, and plug in the point and the slope, and that would be our answer. But since we're not given that, we have to come up with another approach. And given that this line needs to be perpendicular to the 2x minus 3y equals 6 line. So that is the key here. It needs to be perpendicular to another line. So the keyword perpendicular. So the key features of lines being perpendicular to each other, it is about their slope. That's the main point. Two lines that are perpendicular to each other, the characteristics or differences between their slope is that the slope of one line is the reciprocal and negative of the slope to the other. So if the slope of say one line is a 2, then the slope of the second line, in order for it to be perpendicular to the first one, it needs to be the reciprocal, so 1/2, and negative. These are what makes these two slopes perpendicular for their lines or equation of the line. So this is what we need. We need two slopes where one is the reciprocal and negative of the other. So with that being said, that leads us to ask ourselves, well, what is the slope of the line that it needs to be perpendicular to? So that is where we start our process. We need to find the slope of the 2x minus 3y equals 6 line first, and then find the reciprocal and negative to get the slope for the line that we're trying to find in slope-intercept form. So first piece, find the slope of the 2x minus 3y equals 6 line first. And that goes back to us putting it in slope-intercept form. So because we need it in that form to identify what is the slope there. So 2x minus 3y equals 6. So this is my first step. Solve for the y. So regular algebra that we've known to do. 3y equals -2x plus 6. Divide both sides of your equation by -3. And we have y is equal positive 2/3 x minus 2. All right. So here I can quickly identify that the slope of this line is a positive 2/3. So that means the slope of our line that we're trying to find, is going to be the reciprocal and negative of that. So that means M2 is going to be a negative 3/2. So now that I have the slope of the line that I'm trying to find, and I have a point for the line that we're trying to find to go through, we can use what's called the point slope form in order to get the equation of our line. So that is what I'm going to do here. So moving over, move it up here. Step 2, I'm going to use the point slope form, which is y minus y1 equals the slope multiplied by x minus x1. Now x minus the x1 and the y1, those represent the point that our line is going through. So that is the point 1, -2. The m, again, that's the slope. And then the regular y and x, those are the variables that are needed for our equation. So we don't plug anything into those. Those are the default variables used for the equation y equals whatever x plus whatever else. So this is our point slope form equation. Our point that we're going to use, 1, -2, and the slope we're going to use -3/2. So with all this information, we're going to plug in. So y minus y1 is a 1, equals the slope -3/2 multiplied by x minus x1. So here I made a mistake, which will happen. But it's fine if we are able to catch it. So y1 is a -2. So I have y minus -2. And x1 is a 1. There we go. Better. So now that we have this, we can simplify and put it in the form that they ask us to put it in, which was the slope intercept form. So that's getting the y by itself. So here, y minus a -2, that makes it plus 2 equals, and I'm going to go ahead and distribute the -3/2 in the parentheses, -3/2 x plus 3/2. And now get the y by itself, -2 on both sides, to get y equal to -3/2 x. So I have a positive 3/2 minus 2. So note this is going to be a negative. So 3/2, that is 1.5. So 1.5 minus 2 is a -0.5, or -1/2. So there we have it. This is the equation of the line that goes through the point 1, -2, and it's also perpendicular to the line 2x minus 3y equals 6. And to see if this checks out, you can use your graphing calculator. Again, you'll need to have both equations in y equals or slope intercept form, because that is what your calculator graph it as y equals. So you'll plug both of those equations in and see that they indeed are perpendicular. So now we're going to move on to the parallel problem. Okay, so now find the equation of a line in slope intercept form that goes through the point 3, -4, and is parallel to the line that goes through the 2 points 0, 2, and 3, -1. So This one here, about the same amount of work we did for the previous one. So let's just go ahead and get started. So first, parallel. So like in the previous one, our key phrase or key term was perpendicular and had to figure out what that meant in regards to the two slopes of the lines. Same a case with this. Our key term is parallel, so we need to know what is the correlation between two lines, the correlation of the slopes between two lines that are parallel to each other. So we said previously, the slope of two lines that are perpendicular to each other are reciprocals and negatives. So the slope of two lines that are parallel, they are equivalent. They have the same slope. Their slope are equals. So with that being said, again, we need to ask ourselves, well, what is the slope of this other line that they're talking about in order for us to find the equation of the line in slope intercept form. So in this case, we need to find that slope for this other line, and then we will be able to get the equation of the line that they're asking for. So we will start with the 2 points that our line is supposed to be parallel to, that it goes through, that the points it go through. So 0, 2, and 3, -1. So we don't need to find the equation of this line because all we need is the slope. Because again, if it's parallel, then that means the two slopes of the line are equivalent to each other. So if we find the slope of this line with those 2 points, then we automatically know the slope for the line that we're trying to find is the same. So we just need to use the the slope formula to figure out what that is. So again, y2 minus y1 over x2 minus x1. So again, just for consistency, our first point is 0, 2, and the second point is 3, -1. So that means our 0 is x1, 2 is y1, 3 is x2, and -1 is y2. So we just substitute. So -1 minus 2 divided by 3 minus 0. This gives me -3 over 3, which simplifies down to a -1. So if the slope of the parallel line that goes through these 2 points is a -1, that means the slope for the line that we're trying to find is also -1. Because again, they are parallel. Parallel lines means they have the equivalent slope. So now that I have the slope of the line that we're trying to find, -1, and I have the point that the line is trying to cross or does cross through, 3, -4. Again, I use the point slope formula to figure out what it is and put it in slope intercept form. So y minus y1 equals m multiplied by x minus x1. And plug in. So y minus y1 is y minus -4 equals the slope, which is a -1, x minus x1, which is the x minus 3. So that will continue on to be y plus 4 equals a negative multiplied by x minus 3, not x minus x, otherwise that would be a 0. I was already going ahead to think about distributing the negative instead of just rewriting it like this. That's why I rewrote the x. But I'll just leave it like it is and redo it on the next line. So y plus 4 is equals to negative x plus 3. And now solve for the y, get the y by itself. So I will need to minus 4 on both sides of this equation to have y equals negative x minus 1. So there you have it. This is the equation of the line and slope-intercept form for our line that goes through that point, 3, negative 4, and is parallel to the other line that goes through those 2 points. So again, if you want to check that these two are parallel, use your graphing calculator to plug them in to your y equals. Now, in order to get the other one that goes through those other 2 points, you'll need to do the same thing. Use the point slope form with that slope and one of those points to get the equation. So you'll have that one as well. And you can plug both of those into your y equals and see that they are parallel. All right. So let's keep on going. We're going to go ahead and go through some more problems. All right, so these are going to be our last 2 problems here. We're going to end it off on a, warm down, if you will. So with that being said, let's go ahead and get into it. We have find the exact distance between 2 points and find the midpoint of a line segment with 2 endpoints. So firstly, finding the exact distance or distance between 2 points. So that means we would need to know the distance formula. So distance formula, that is d is equal to the square root of x2 minus x1 squared plus the y2 minus y1 squared. That gives us our distance. This is our distance formula that we will be using. So again, just like with the slope formula, the x1, y1, and x2, y2, those corresponds to the 2 points that are given. So in this case here, x1 is negative 3, y1 is 1, x2 is 2, and y2 is the 4. So we just go ahead and plug in. So that will be the distance of these 2 points is going to be the square root of x2. So that's 2 minus x1. x1 is a negative 3, so I have 2 minus negative 3 squared plus y2, which is 4, minus y1, which is a 1, squared. And now I just evaluate. So 2 minus a negative 3, that's a 2 plus 3 squared plus, and I'm going to keep the 4 minus 1 squared. And now I can evaluate inside the parentheses. 2 plus 3 is 5 squared. And if you want to go ahead and do all of that as well, you can. 4 minus 1 is 3 squared. Five squared, 25. 3 squared is a 9. Add those 2 values together. 25 plus 9 is a 34. And now we can't take the square root of 34. It's not a perfect square, but let's see if we can simplify it, if we can simplify this radical. So I need the factors of 34. That is, we have 2 and 17. 2 is already prime, 17 is prime, and neither of those are perfect squares. So I cannot simplify the square root of 34. So therefore, the distance, the exact distance between those 2 points is the square root 34. Yep. So that's why they did insinuate on saying finding the exact distance, because they knew it was going to come out as a square root something. So you don't want to use the rounded value of whatever the square root of 34 is. You just keep it as the square root of 34 or the square root of whatever. And if it could have been simplified, you would simplify it as that. Yep. So now, let's go ahead and moving on to the last one. All right, so finding the midpoint of the line segment with endpoints -1, 1 and 1, 0. So midpoint formula. Midpoint formula. See. Midpoint formula. We have, if we were dealing with, just numbers in general on a number line, and we wanted to find the midpoint between, 1 and 2, then we would do, the 1 plus the 2 divided by 2. That would give us that midpoint, or whatever the value is in the middle of those two numbers. So since we are dealing with points that have an x and a y value, the midpoint is the same, but it has more in it, since again we're dealing with x and y values. So whenever we're trying to find the midpoint between 2 points, 2 order pairs, that midpoint formula will be x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. This will give us the order pair that is in between, or midway between those two endpoints. So again, y1, x1, y2, x2. One. So now all we have to do is just plug it in. So x1, -1 plus 1 over 2. See, my brain is working ahead, and that'll happen sometimes. That's okay. That just means we have to slow it down just a bit. We know it's when we know something is a very easy problem, that gives us more opportunity to make a mistake, actually. So we just have to take our time, slow it down, and make sure we are writing and labeling everything correctly. So now y1 and y2, 1 plus 0 over 2. So evaluating this out, -1 plus 1 is a 0. 1 plus 0 is 1. So finishing this out, 0 divided by 2 is 0, and then 1/2. So that would mean the midpoint between those two endpoints is 0 and 1/2. And I can draw a little line here. So let's say this is my 0 line here. So this is my regular number line. So I'm just doing the x values here. So the endpoint, -1, 1, and 1, 0, the x values on those is -1 and 1. So -1 is here and 1 is here. So the point that is directly in the middle of -1 and 1 is a 0. That is correct. So now let's see about the y values. So I'm just going to draw another number line, but use the y values of those endpoints. So let's say here's my 0 line, so I can know where to put the numbers. Let's see. So 1, that's the y value for the first endpoint. And the y value for the second endpoint is 0. So, okay, I have that there. So the midpoint that is between 0 and 1, well, is the middle, is exactly halfway between the 0 and the 1. And that's the 1/2. And that is exactly the point or ordered pair that we came up with for the midpoint of these two endpoints, 0, 1/2. So that is correct. All right, you guys, that would be the end for this video. If you end up having questions, or may have had questions even in the previous videos, more so about where the formulas have come from, what makes two lines perpendicular to have slopes being reciprocal and opposites, or parallel line slopes being equivalent, like what makes those things that, like how do we know that those rules are set that way? Same thing with midpoint, distance formula, those type of questions, those how questions. I can make more detailed videos. They will most likely be on my Patreon. So if you want to go over there to watch those videos, you can. So by the time this video came out, and I'm telling you this, my Patreon would have already been up. So there will be a Patreon for you to go to, and the link for that stuff will be in the description below. So yes, and other things, if you want to know how, more so than how that formula came to be, or if you want to say why, you can, but I advise you not to. It's more so how or what makes this formula work. I can make those type of videos as well. If you want me to, because I know most people have those type of questions versus how to do the problem. I mean, you have most people, and I've been like this for a while. They can do the problem, like just copy and paste. They can copy exactly how to do a problem. All you need to do is just change the numbers and stuff. And if you got the formula, you're all good. You know how to do the problem. But if you're looking for, what makes this formula work, or what makes this problem the way it is, I can make those type of videos as well. But those would be more, exclusive videos, because I would be putting a whole lot more time into explaining those types of problems. So those will be my like history types of problems, and how you're able to derive those types of problems or formulas. So getting a better understanding conceptually of what math is versus how to do the math. So two different sets of things we're working with there. So if you want that, go over to my Patreon and support me. That would be incredible. That'll give me even more energy to do these type of videos that I already like to do, and I can make it even more cooler. With any type of like effects or whatever. Just go all out with it. But as of right now, this works, and getting a better setup or plan on how to do this and make it more presentable for you guys. So yes, with that being said, again, that would be the end of this video. I hope you guys enjoyed it. You know what to do if you did. Like, share, subscribe. Get this out there to all the nerds in the universe, multiverse, and alternate dimensions. And I will see you in the next one. The Immortal Nerd signing off.